Welcome all. In this video, we will learn about Thevenin's theorem. Students will be able to analyze the circuit using Thevenin's theorem. Thevenin's theorem states that any two-terminal linear bilateral network can be represented as a series combination of VTH and RTH, that is, Thevenin's voltage and Thevenin's resistance. And VTH is the open circuit voltage measured between A and B after disconnecting the load resistance RL. RTH is the Thevenin's resistance measured between A and B by reducing the independent sources in the network to zero. Independent voltage source is reduced to zero by short circuit and independent current source is reduced to zero by open circuit. For solving a network using Thevenin's theorem. First one is disconnect the load resistance RL and then calculate the Thevenin's voltage using loop analysis or nodal analysis or series parallel reduction. And then calculate Thevenin's resistance by series parallel reduction. Draw the Thevenin's network and calculate the load current by connecting load resistance between these two terminals. That is the total voltage we have to find out. The Thevenin's voltage we need to find out. And the formula used for finding the current, load current is equal to VTH by RTH plus RL. Circuit shown below, load resistance is there. First we need to disconnect the load resistance and then calculate the voltage across A and the two terminal A and B, and then by using the formula of Ohm's law, that is VTH is equal to I R2 is equal to V by R1 plus R2 into R2, and then calculate RTH, the total resistance or Thevenin's resistance, that is equal to it's parallel, that's why we use the parallel formula, that is R1 R2 divided by R1 plus R2. Norton's theorem. Norton's theorem states that any two-terminal linear bilateral network having active and passive elements can be represented as a practical current source with IN and RN. And IN is the current flowing through the short circuit placed between A and B, and RN is same as RTH, that is the resistance measured between A and B by reducing the energy source to zero. For solving a network using Norton's theorem is first one is replace load resistance RL with a short circuit and then calculate current through the short circuit using loop analysis or Ohm's law or current division rule, and then calculate Norton's resistance looking from A and B, and then calculate IL using current division rule, that is IL is equal to IN into RN divided by RN plus RL.